Hello and welcome back to another Math 104 lecture. Today what we are going to be looking at is we're going to be examining graphs of equations. So in the last lecture, we looked at the coordinate plane. We looked at, how that was essentially two number lines just overlaid on top of each other, just, perpendicular to each other. We practiced plotting some points and whatnot. So today we're going to be looking at some, equations that we've been dealing with, pretty consistently, like linear equations, quadratics. And we're going to see how this is actually going to look on a graph when we plot it out. So before we get started, there are two definitions. I mean, it's really just one, but two definitions that you should be aware of, and that's dependent and independent variables. Okay, so let me write a example on the board here that basically everybody and their mother has seen before, assuming you could understand my handwriting. Y is equal to mx plus b. Right? Now, say, whoa, did not mean to open Excel. Hopefully that was not captured. Okay, anyway, so say we have, this linear equation here, right? Y is equal to mx plus b, which we are probably aware of. And we'll talk about this later in the chapter on lines that's coming up in the next lecture. But I'm just bringing this up now because, again, it's something that we're probably familiar with, right? So what is this? Well, x is a variable that we care about. Y is also a variable that we care about, right? And when we put them together, we get ordered pairs, right? Depending on what we plug in for x, it's going to be augmented by m and b, right? We're multiplying x by m, and then we're adding something to x as well. And then there's going to be some output, which is y, right? So when it's all said and done, we plug in something for x, and then, we go through the operations of multiplying by m, adding b, and then we get some output y, right? And then this is how we get ordered pairs. So you see that a line is really just, a large majority of just, a huge collection of ordered pairs. That's all a line is. And as it turns out, that's all any equation is. When we have a graph of an equation, it's just a series of plugging in something for your independent variable. Remember, your independent variable in this case is going to be x, because your independent variable is something that we're choosing that number to be. Y is dependent on x because depending what number we fill in for x, is going to have some sort of operation, m times that number, and then we add b to that number afterwards. That's how we get y. Y is dependent on what we plug in for x. Now, sometimes it's not exactly clear what's the dependent variable and what's the independent variable. Like, say, for example, we have x squared plus y squared is equal to 1. And we're going to see this equation two more times when we come throughout this video here. But it's really hard to say which is the dependent variable and which is the independent variable. Because if we plug in, values for x, is that really directly corresponding to y? Is that, is what we plug in for x going to affect y? Well, not in its current form, right? You would have to solve for a particular variable, and whatever variable you end up solving for, that will be your dependent variable, right? And so once again, if we go back to our y is equal to mx plus b example, y is equal to mx plus b. Notice how this is solved already for y. Y is isolated. Y is entirely by itself, right? This is by design. We normally, when we talk about equations, we normally talk about x being the independent variable, y being the dependent variable. So you were probably introduced to y is equal to mx plus b because, again, this is just how we colloquially talk about dependent and independent variables. But that's not to say that we couldn't also just solve for x instead, right? So if we wanted to, if we really wanted to change which is the dependent variable and which is the independent variable, we could. We could move the b over and we could say, okay, y minus b, and then we could divide the m, right? So we divide both sides by m, and now we've solved for x. And what this shows now is that this says that, okay, well, great, this is the same exact equation, but now y is our independent variable, and x is dependent on what we plug in for y. Right? If we plug in numbers for y, then we're going to subtract something away from it. We're going to subtract some b away from it, which is b is just some number. We're going to divide it by some other number. And then finally, we have a solution for x. So as you can see, dependent and independent are terms that we, use strictly for how the equation is given to us in its, in its current form. And we can always manipulate it to be such that one is dependent and one is independent after the fact. Okay, so don't get too hung up on the definitions. It's really just, showing you that when you solve for a variable, that variable will almost always be the dependent variable. When you've solved for a particular unknown, that will generally be your dependent. And whatever is your other variable, in this case, we normally say x, that's generally your independent. Okay, so let's go ahead and let's look at the graph of, let's say we have y is equal to x squared minus 4. Okay, so what I want to do here is to graph this, I obviously need, like we just talked about, we need ordered pairs, right? We need points that we can put onto a graph. So we don't necessarily know what those points are yet, right? So the best way that we can figure out some points is we just plug in some values for x. X is our independent variable, so we can just throw in any number. Then we chug through the operations and we get our answer for y, which is our dependent variable. So I'm going to make a little table of values here, right? So over on this side, I'm just going to make a table. And making a table, here are my values for x. Here's y is equal to x squared minus 4. And finally, here's going to be my ordered point or ordered pair output. Okay, so xy. Okay, so let's just run through some points, right? I'm going to go from -3 to +3. So -3, -2, -1, 0, 1, 2, and finally 3. And we're going to see what we end up getting for everything. Okay, so plugging in -3, well, you're plugging in -3 for x, right? So plugging in -3 for x, you get y is equal to -3 squared. And I'm not going to write this every time. I'm just, showing you guys how to plug in the numbers. So, y is equal to -3 squared, -3 squared minus 4. And -3 squared is the same thing as 3 squared, right? Because the negatives are going to cancel. We get 9 minus 4, which gives us 5. Okay, great. So we get 5. So 5 is our first y that we got by plugging in -3, which means our first ordered pair is -3, 5, right? We plugged in -3 for x. We got 5 as an output, so we have that point. So next, we're going to plug in -2. So plugging in -2, we get -2 squared, which is 4, minus 4, so we get 0 here. And as a result, that means we get -2, 0. Okay, -1. So -1, you get 1 back. When you square it, you get 1 minus 4, which is a -3. So -1, -3, and 0, well, this isn't too bad, right? 0 squared, 0 is just 0. So 0 minus 4 is -4. And so this ordered pair is 0, 4. And now, as you might imagine, well, what's going to happen when we end up squaring the positive values? Well, it's going to repeat the same answers that we got by squaring the negative values, right? Because by squaring the negative values, we got the positive answer anyway. So let's see what happens when we square +1 instead of -1. Well, +1 squared is going to be 1 squared minus 4, which still gives us -3. So we get 1, -3. And the only difference between this guy and this guy is the sign of our x component, right? We started with a -1 the first time we did it. Now we started with a +1. But notice that our y component is still -3. And that's kind of just the nature of quadratics, is that your output is eventually going to start to repeat. Not necessarily your input and not necessarily your ordered pairs, definitely not your ordered pairs, because again, notice that -1, -3 is not the same as 1, -3, but your output for plugging in, a number for x will start to repeat on both sides. Okay, so now we plug in 2. 2 squared is going to be 4. 4 minus 4 is going to be 0. So now we have 2, 0 as opposed to -2, 0, which is what we had above. And 3, we plug in 3, which is 3 squared is 9 minus 4 gives us 5 again. And so we have +3, 5 as opposed to the -3, 5. So again, you can see if you're just looking, and I'm just going to circle these in green here. If you're just looking at the outputs, the y outputs, you can see a repetition, right? We have 5, 0, -3. That's a -4, although I'm not 100% certain I wrote that. Nope, I definitely did not. I missed the negative sign. Sorry. -4. So we have 5, 0, -3, -4, and then it starts to repeat, right? -3, 0, 5, and it goes on, on both sides to infinity, right? Okay, so what's the point of this? What do these points do for us? Well, remember, a graph is just a series of ordered pairs, right? So if we go to graph this, and that's exactly what we're going to be doing over here. So bear with me. I'm going to use the ruler here just so it comes out looking pretty nice. So using the ruler. See, look at that nice straight line. Doesn't that just make your OCD happy? It makes my OCD very happy. Okay, so we have that, and over here we have that. Okay, and now what we're going to do is we're just going to try to plot some of these points. Same thing that we practiced in the last lecture, right? Just plotting regular points. So we're going to need from the, as far as the x-axis is -3 to 3. So we'll say that this is 1, 2, 3, and over here this is -1, -2, -3. And this is not drawn to scale, so if it's a little off, it's a little off, and that's okay. And for the y components, we need to go down to -4 and up to 5. So we'll say, okay, well, 1, 2, 3, 4, and 5, and -1, -2, -3, -4. Okay, perfect. So let's start plotting some points. So first point is -3, 5. So -3, 5 is going to be -3 and 5, which is right up here, right? Okay. Then we have -2, 0. So -2, 0 is going to be just right on the x-axis. We have -1, -3. So that's going to be right here. And then we have 0, -4, which is on the y-axis, right? It's 0 implies, there's no movement in the x direction, and it's purely just 4 units down because it's a -4 on the y-axis. And then it starts to repeat, but just on the other side of the x-axis, right? So now we have +1, -3. Then we have +2, 0, and then we have +3, 5. So that's going to be somewhere right around here. And as you can see, we have sort of this nice U shape going on, and I'm going to butcher this while I draw it. I apologize. You know what? It actually wasn't so bad. Okay, so we have this nice U shape going on, and what this is called a parabola. And in general, in most math classes, they will put these arrows to show that it goes on to infinity because x squared will just get larger and larger and larger, right? Depending on obviously the numbers that you plug in, but it goes on to infinity is the point. But this again, the thing that I want to note here is that this U shape is called a parabola, and parabolas occur essentially whenever you have a quadratic equation. So whenever you have an x squared as your highest power, you're bound to get a parabola. Now, the only thing is that, it does depend on your dependent and independent variable. So here we have x squared being our, we have x being our independent variable. So as a result, the parabola is, opening upwards, right? If y were our independent variable, then we'd have something looking like that, where the U shape is opening up to the right side. And we'll actually see that shortly later on when we go through this video. But again, so the point that I'm making here is that for graphing this, all we do is, we just plug in some sample numbers into x or into our independent variable. We do the plug and chug, the actual calculation, and then we get our final ordered pairs, which we can then plot onto a graph, and that'll give us a nice good sketch, a nice representation of the graph of the equation that we were dealing with. Okay? Okay, so for the record, it is of no it's no coincidence that our graph was x squared minus 4, which I really want you to remember, x squared minus 4, difference of squares, right? Difference of squares. And now what I want you to think about is what happens if we had, instead of y is equal to x squared minus 4, what happens if we had 0 is equal to x squared minus 4, and I said solve for x, right? Well, you would solve for this by saying, oh, well, this is difference of squares. You would factor it by difference of squares, and you would get 2 solutions, right? Keep those solutions in the back of your head because that's going to come up in just a second here. But notice, again, it's of no surprise that it's crossing the x-axis at -2 and +2, okay? Okay, so let's go ahead and talk about intercepts. So intercepts, the definition of an intercept is the point at which the graph intersects with a particular axis. And in general, you're going to have intercepts always in the form of it's either going to be something like a, 0 or 0, b. depending on which intercept you're talking about, right? If you're talking about the x-intercept, then if it's crossing at the x-axis, well, y is going to have no component, right? Notice on our graph here, the point -2, 0, and 2, 0, those intercepts, those have no y component attached to them, right? It's 0 in either direction, up or down. It's just purely at, -2 on the x-axis. And so over here, 0, comma b, this is where you would have your y-intercept. So y-intercept, again, looking at our graph from above, we have a y-intercept at 0, -4. And again, it's 0 for the x component because it's not moving in either direction, left or right, right? So where it's just going down and it's crossing the y-axis at -4. Okay, so this is how you would write your intercepts in point notation. Sometimes we just generally write the intercept as x is equal to whatever the number is and y is equal to whatever the number is, and we'll see that in just a second here. Okay, all right, so let's go ahead, clear this off, let's make some room for ourselves, and let's move on to an example with finding intercepts. So let's say we is equal to 2x squared plus 3x minus 2. So the way that you find a particular intercept, be it the x-intercept or the y-intercept, is you set the opposing variable equal to 0. What do I mean by that? I mean that if you're looking for the x-intercepts, you set y equal to 0, and then you solve for x. And if you're looking for the y-intercepts, then you set x equal to 0, and you solve for y. Okay, so let's do both. So what we're going to do here is I say I want to find both the x-intercepts and the y-intercepts to the equation up here. Okay, so I'm just going to abbreviate this as x-int, x-intercepts. So again, our procedure is now, because we're looking for the x-intercepts, we're going to set y equal to 0. So that means we're going to have, wherever there's a y, we're going to set that equal to 0. And in this case, there's only one instance of y. So we have 0 is equal to 2x squared plus 3x minus 2. Okay, and now we just solve for x, right? So how do we solve for x? Well, solving for x, we see that we have a coefficient of 2, right? So we have to do our a times c normal factoring stuff. So a times c is 2 times -2, which gives us -4. We have to look at factors of -4 such that they multiply to give us a -4 and add to give us a +3. So the two that come to mind are +4 and -1. So we split this up into 2x squared plus 4x minus x, or minus 1x, however you want to think about it, but minus x minus 2. Okay, so now we have 0 is equal to, and I'm going to group them, right? We do our grouping steps. So we have, and I'm going to group them as such. I'll put the plus sign in between. So we have 2x squared plus 4x. What is the largest piece that I can take out of that? Well, that's going to be a 2 and also an x, right? So now we just have an x left over plus 2 over here. And now, once again, as you see, and as a common theme for when we factor by grouping, this inside parentheses here gives you a clue for what you're looking for, right? So because we're looking for an x plus 2 and we have a negative x and a -2 here, we can just say to ourselves, oh, we can just pull out a negative sign. And if we pull out a negative sign, then we're just left with the flip signs, right? We flip the signs of -x, we get a positive x. We flip the signs of -2, we get a +2. So x plus 2. And great, we have exactly what, we have the same term, so we can do that distributive process in reverse, which means we're going to pull out x plus 2 from both terms, and that leaves us with 2x minus 1. And if you're confused where the 1 came from, always remember that there's a hiding 1 here at the negative sign always, right? If you don't see the number there, it's a 1. So that's where the 1 is coming from. Those are our two pieces left over, the 2x and the -1. So we see here that we have two factors. We have 0 is equal to x plus 2 times 2x minus 1. And we know then that we can just solve this. We can split it up by the zero product property. We solve for both of them. And solving for both of them, I'm just going to skip a step here, but we get x is equal to -2. And also x is equal to 1/2. Okay. And feel free to, if you don't see it immediately, solve for both of the factors. You'll get the same thing that I just got. Okay, so we get x is equal to -2 and also 1/2. What does this tell us? Well, remember, going way back over here, the whole point of this was to find the x-intercepts, right? So this tells us that for the equation y is equal to 2x squared plus 3x minus 2, at these specific points, when we plug in these numbers for x, there is going to be no y component. We are going to always arrive at -2, 0, and also 1/2, 0. This tells us that at these two values, we are crossing the x-axis, and that's it. We're on the x-axis. It's not, the point is not above the x-axis. It's not below the x-axis. It's directly on it. Okay, so that's how we find the x-intercepts. As far as the y-intercepts are concerned, well, that's actually going to be significantly easier. And why is it going to be significantly easier? Well, again, our original equation, I'm just going to write the original one more time. We have y is equal to 2x squared plus 3x minus 2. And remember, whenever we're solving for the intercept of one variable, we set the other variable to be 0, right? So when we set x to be equal to 0, we're going to see this term cancel out because 2 times 0 squared is always going to be 0. 3 times 0 cancels out, right? And we're just left with y is equal to -2. And that's it. So as you can see, whenever your y is your dependent variable, the intercept, the y-intercept, is just going to be the constant that's left over. Because anything that has an x attached to it is just going to be 0 because you're making x equal 0 to find the y-intercept. So what does this tell us? This tells us when y is equal to -2, there is no x component whatsoever. We would arrive at the point 0, -2. Okay, so all this tells us is this helps us plot the graph. It helps us, get more accuracy to the graph because it tells us exactly when and where the equation is hitting our axes. Okay, so with that being said, what I want you guys to do is I want you guys to find the first classwork assignment. And in the first classwork assignment, I want you guys to give me both the x-intercepts and the y-intercepts. Okay, so again, just the process for it is you would go through for the x-intercepts, you set y equal to 0, you solve for x. For the y-intercept, you set x equal to 0, and you solve for y. Okay, so take a couple minutes, see what you get. Okay, so the classic equation for number 1 is y is equal to x squared minus x minus 2. Okay, so x squared minus x minus 2. So for our x-intercepts, what we have to do is we set y equal to 0, right? So we have 0 is equal to x squared minus x minus 2. And okay, we see we just have a regular quadratic equation now. So we need to just, try to factor if we can factor. If we can't factor, then we resort to the quadratic formula, right? So trying to factor here, we look at our factors of -2 because a, our coefficient of x squared, is just 1. So we don't need to do a times c. So we have -2, and we're looking at factors of -2 that it'll multiply to be -2 and add to be -1. So I think this one's pretty easy. -2 positive 1, right? And when we split this up, we get x minus 2 times x plus 1. And solving for both, we get x is equal to -1, 2. And this tells us that at the points -1, 0 and 2, 0, there are no there is no y component to these ordered pairs. Again, these are our x-intercepts, so you know that the y component is just going to be 0 by default for the ordered pairs. So that means you could just plug in your x component and you'll have, whatever it is, comma 0. In this case, -1, 0 and 2, 0. So now we just have to find our y-intercepts, and finding our y-intercepts, once again, proves to be a little bit easier, right? So finding the y-intercepts of this, we see that our original equation was y is equal to x squared minus x minus 2. So setting everything else, so all the x's equal to 0, we get 0 squared minus 0 minus 2. And once again, we see that, oh yeah, all the zeros are going to cross out, right? And we're just left with our constant at the end. So we just see that this constant ends up being our y-intercept. And so we're just left with y is equal to -2, which once again tells us our ordered pair, if we were to plot this, would be at 0, -2, because there is no x component on a y-intercept. Okay? So before we move on to the next subject, what I want to talk about is, remember I told you guys to keep in mind that y is equal to x squared minus 4, right? And when we graphed it, we saw that the intercepts of the x-intercepts were at -2 and 2. And according to what we just did, well, that should make sense, right? Because when we solve for the x-intercepts, it would be 0 is equal to x squared minus 4. And solving that, you would get x is equal to plus or minus 2 by difference of squares, right? So what happens if we have something like y is equal to x squared plus 1? Well, if you guys remember, when we looked at this before, and the way that we looked at it before was we set it equal to 0, right? We had 0 is equal to x squared plus 1. And we talked a little bit about imaginary numbers, if you guys recall, right? So I said, okay, well, how would you possibly solve this if you can't factor it? And one way that you could try to solve it is you would move over the 1. So you would have -1 is equal to x squared. You would square root both sides. And we saw that the square root of -1, we call it the imaginary number I, right? It's the base unit I. And obviously square root plus or minus, right? We get two solutions. So the thing that I want to draw your attention to is that the number of intercepts directly corresponds to the number of solutions that you can have for your equation. So we see that because there's no real solutions, and of course, you know, since we're only talking about real solutions, you wouldn't even talk about imaginary numbers here. There are no solutions to this equation, right? 0 is equal to x squared plus 1. There's no real solutions. There's only complex or imaginary solutions, which are outside the scope of this class. So as a result, try to graph this. What is x squared plus 1 when you try to graph it? Well, trying to build a little table, and I'll go through this one a little faster. Let's say we had -2, -1, 0, 1, and 2, right? Okay, so going through this one a little faster, -2 is going to be 4 plus 1 gives us 5. Then we have -1, which is 1 plus 1, which is 2. And 0, well, 0 squared is 0 plus 1 is 1, right? And then you see it starts to repeat, right? We have 1 squared, which is 1, plus 1 gives us 2. 2 squared plus 1 is, again, 5, right? So, and I'm not going to even bother using the ruler for this time. So plugging this in onto our coordinate plane here, we see that we have to go up to 5, and we have to go all the way down to -2 and 2 on the x-axis, right? So -2, -1, 1, 2. And over here we have 1, 2, 3, 4, 5. Okay, so how's this going to look? Well, again, we have -2, 5, right? So that's going to be somewhere about here. We have -1, 2, so that's going to be somewhere right about here. I know I didn't label the y coordinates, so I apologize. I'll do that real quick. Okay, and now we have 0, 1, right? That's going to be our coordinate pair. So 0, 1. Well, 0, 1 is 0 in the x-axis and 1 up on the y-axis, right? So as such. And then we start going back up, right? 1, 2. That's going to be right here. And then 2, 5, which is once again like right over here. And it's not necessarily drawn to scale, but I think you guys get the picture that we can see that x squared plus 1 never touches the x-axis. So it should make sense that because we have no real solutions for this equation, we can't factor it, we can't use the quadratic formula, everything's going to not work, right? Because we have no real solutions, it should make sense that this equation also never touches the x-intercept. Or I'm sorry, the x-axis. We have no x-intercepts. Again, remember, the x-intercepts directly correspond to your solutions of the equation. So if there are no solutions, there's no intercepts on the x-axis, which we can see right here as such. Okay? All right, so let's move on to a different topic. Now we're going to be talking about symmetry. So symmetry of a graph is where one portion of the graph has a mirror image as another portion on the graph. So there's 3 kinds of symmetry. There's going to be symmetry with respect to the y-axis. So just doing a quick sketch, we already kind of talked about parabolas, right? And we saw that the U shape, we saw how it kind of mirrored over from one side to the other, from the left to the right. Well, yeah, that's symmetry across the y-axis. So this is the y-axis, this is the x-axis, and you can notice that when you're talking about the first quadrant, so remember your quadrants, right? Quadrant 1 is right there, quadrant 2 is right here. You can see that quadrant 1 and quadrant 2 are just mirrored over the y-axis, right? So we see that we would say that, parabolas, assuming they're starting, at 0, 0, which is what this one is starting at, the origin, right? This would have symmetry in regards to the y-axis. Then there's also going to be symmetry in regards to the x-axis. So in regards to the x-axis, it's going to look very similar, right? And I'm only just using parabolas as just a base case because now, we see that we're actually familiar with parabolas. So we're going to look at something like that, where again, this is quadrant 1, quadrant 4, right down here. And we can see that, oh yeah, so when we have a graph that's like this, we see that it's symmetric with regards to the x-axis. It's almost like, you take a piece that's in the first quadrant and you just roll it over into the fourth one, right? And the only thing that's happening is that the y component is becoming negative, right? Positive up here and negative down here. Okay, and now the last sort of symmetry that we have is symmetric with respect to the origin. So that means if we have something like this, well, symmetric with respect to the origin is where we have something like a line passing through the origin. And it doesn't have to be a line. This is, again, just a rough example to show you guys. You see, oh yeah, no, it doesn't matter. When we go through the origin, it's going to be the exact same image across this line as, across the dotted line on the other side, right? So there is symmetry in regards to the origin as well. So to test for symmetry, we have 3 ways to test, and it's one for each symmetry, right? We talked there's symmetric about the y-axis, symmetric about the x-axis, and symmetric about the origin. So there's a test for each case. So to test for the y-axis symmetry, what you want to do is in your equation, whatever your equation is, you want to replace x. So replace x with negative x. Okay, so wherever there's a positive x, you just want to switch it to a negative x. And if your equation still produces the same result, then your graph is going to be symmetric about the y-axis. Again, what you're looking for is you're looking to do a couple operations on your on whatever your x is, but in this case, instead of it being x, it's going to be negative x. Okay, so your x-axis symmetry, as you guys might already intuitively be able to figure out, is you're going to replace y with negative y. Okay, so all you're going to do is, once again, you have whatever graph or equation that you have in front of you. Wherever there's a y, you're going to plug in negative y. You're going to try doing some operations to it, and you're going to see whether or not we get the same equation back anyway. If we get the same original equation back anyway, then it's it's symmetric with respect to the x-axis. And then the last one is for the origin. So origin symmetry. Well, what you want to do is you want to do both. So what you want to do is you want to replace wherever there's a y, you replace it with a negative y, and wherever there's an x, you want to replace it with a negative x. And you want to see if the, again, the equation that you're given still will be the same thing as the original. So I know that might seem kind of wordy and it might not seem exactly clear. So let's kind of jump to an example here and see if this one pans out. Okay, so I'm just going to clear this off here. Hopefully you guys have it written down. If you don't, just go back into the video. So our example that we have is, let's say I give you x squared is equal to y cubed. And I say, I want you to determine whether this is symmetric about the y-axis, x-axis, and the origin. So you're going to do all 3 tests, okay? So for the x-axis symmetry, so x-axis sim, I'm just a big fan of abbreviating, especially when I'm writing. So for the x-axis symmetry, we're going to replace all of the y's with negative y's. So we see here that this means we're going to have x squared, right? We're not touching x, we're just touching y. And wherever we have a y, we're plugging in negative y. So we have negative y cubed. Well, now all we have to do is we just have to figure out the sign of negative y, right? If it's positive, then, after we do the cube to it, then, okay, great. We get the same original equation back, right? This is our original equation. X squared is equal to y cubed, where obviously this is positive and also this is positive. So if we get positives back, then great, we're done. It's symmetric. If we get a negative back, though, then it's not symmetric, and we've shown that. Okay, so what happens when we cube a negative number? Well, we know that this is the same thing as x squared is equal to negative y times negative y times negative y, right? And we know that negatives cancel in pairs, so we cancel like that, right? And we're left with one negative remaining. So we're left with x squared is equal to one negative left on the outside, and then y times y is, again, y cubed. And notice this is different than the original equation, right? Now we have x squared is equal to negative y cubed, and that's different than x squared is equal to y cubed, right? So we see we do not get the same original equation back, so it is not symmetric, okay? You would write not symmetric. I'm writing an X here because, again, trying to save time wherever I can. So it is not symmetric about the x-axis. So now we move on to the y-axis. So y-axis, we're going to see, okay, is this symmetric? And the way that we test symmetry with the y-axis is we replace x with negative x. So instead of it being x squared, we're going to have negative x squared is equal to y cubed. Well, we already know, and you can do this in two ways. You can either do it the way that we just did above, where you literally list out every single element, right? And that would look something like, okay, you would have negative x times negative x, and we know that negatives cancel in pairs, so we'd get a positive, right? So that's one way to think about it. Another way to think about it is, well, we already know that any number squared is the same thing as that negative number also being squared, right? 2 squared gives you 4, the same way that negative 2 squared also gives you 4. So we already know that negative x squared is still going to return x squared, positive. And because we haven't touched y cubed, it's still y cubed. And oh yeah, look, we get the same exact equation that we started with. X squared is equal to y cubed. So yeah, it is in fact symmetric about the y-axis. And last but not least, to do the origin. So to test the origin here, we just say, okay, we're going to do both, right? We're going to flip both here. And flipping both, we get negative x squared is equal to negative y cubed, right? Again, wherever there was an x, we flip it with a negative x. Wherever there was a y, we flip it with a negative y. That's our test for the origin symmetry. And for this, we get x squared back, same as we did above. And for here, we get negative y cubed back because, again, that's the same thing that we had over here, right? We had the negative y and we were cubing it. We found that there was still one negative left over, and it's the same thing over here. We still have one negative left over. So we have x squared is equal to negative y cubed, which is not the same equation that we started with. So it is not symmetrical about the origin. Okay? Okay, so what I want you guys to do is go ahead. I want you to try your hand at the second classwork assignment, which is x squared plus y squared is equal to 1. And I wanted to see if you guys can figure out if this is symmetric about the y-axis, x-axis, and origin. Okay, so test all three, see what you guys can come up with. And I'm going to have a drink of water. 1 second. Okay, so x squared plus y squared is equal to 1. So to test our y-axis symmetry, so y-axis symmetry, we know that we're going to flip wherever there was a negative, wherever there's an x, we're going to put a negative x, right? So we're going to have negative x squared plus y squared is equal to 1. And when we do this, we know that negative x squared is the same thing as x squared. So we get x squared plus y squared is equal to 1, which, yeah, that's the exact same equation that we started with, right? Similarly, when we do the x-axis symmetry, we are going to flip our y to be a negative y. So instead of y squared, we now have negative y squared, and this is equal to 1. And when we plug this in, we still get x squared down here plus, and we know that, again, any negative number being squared is the same thing as any positive number being squared, so we just get y squared back, and x squared plus y squared is equal to 1. Yeah, this one works too. So now we just have to check the origin. So checking the origin symmetry. Well, checking the origin symmetry is just doing both of the other ones at the same time. So that means we're going to get negative x squared over here. Oops. Ooh, the square should be on the outside. Rookie mistake. Rookie mistake. So negative x squared there plus negative y squared over here. And following exactly what we did above, nothing's changing, right? Negative x squared is the same thing as x squared. And negative y squared is the same thing as y squared is equal to 1. And yeah, we see that it is also symmetric about the origin. So this is a good example to show you that you actually can have cases where all three are going to be the case. And we'll talk a little bit more about what x squared plus y squared is equal to 1 towards the, probably, I think it's actually the next section, right? Yeah, it's in the next section. So this is coming up real soon. But again, I just thought that this was a good example to bring up because you might be thinking, oh, well, if it's symmetric about the x-axis, there's no way it's also symmetric about the y-axis, or there's no way it's symmetric about the origin. Well, yeah, there actually can be. Having one does not exclude the others. Okay, so it's good to keep in mind that just because it's symmetric about, say, for example, the x-axis, it could also still be symmetric about the y-axis and the origin as well. Okay, so hopefully this wasn't too bad for you guys. Again, the key here is just recognizing what happens when you take a negative number and squaring it. And yeah, negative number squared is the same thing as that same version of it, just, positive also being squared. You get the same thing back. So let's go ahead and clear our canvas here and move on to the next section and the last section of this lecture. So we're going to talk a little bit about circles. So if we're talking about circles, then let's say we have AB, and let's say that AB is the ordered pair that is going to be the center of the circle, okay? And it's always going to be distance r away from any other point that lies on the circle, okay? So is distance r away from any other point, right? And we call this distance r its radius. This is the radius of the circle. So when we put this into the standard form of a circle, the standard form of a circle is as follows. It's going to be x minus a squared plus y minus b squared is equal to r squared. Notice, again, I just really want to hammer this down. Two things. This is not the radius. This is the radius squared, right? R is your radius. R squared is your radius squared. So to find the radius, you would have to take the square root of r squared, right? So that's the first thing. And the second thing is notice that a and b are already set to, in this case, we're just going to call them positive numbers, right? Well, the negative number, the negative is already built into the equation. So if a were negative, you would have x minus a negative number. So that would look like x plus something. So I don't want you guys to get confused if you see something in the form of x plus a, or let's say x plus 3 squared plus yada, 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 because what this is going to tell us is this is going to tell us that the component, the x component for the center of the circle is actually going to be a negative 3. Again, we already have one negative built into the equation here. So another negative, or a or b for that matter, being negative, tells us that the center of the circle for that component is also negative. Okay? All right. So let's go ahead and think about this. Well, what happens if the circle is centered at 0? We already talked about AB. We're going to call A comma B. That's going to be the ordered pair that we describe the, the center of the circle, right? So if it's centered at the origin, that means A and B is really just 0, 0. And that means that we can simplify this to be, well, this is really just then x minus 0 squared plus y minus 0 squared is equal to r squared. And when we simplify this, x minus 0 is just x, and then we have x squared here. Same thing over on this side. We have x squared plus y squared is equal to r squared. And when r is 1, r squared is also 1, and you would have, and I'm just going to write this in green because r is not always going to be 1, but x squared plus y squared is equal to 1, and we call this the unit circle. The unit circle comes in into play quite a lot. It's not going to be super big in this class, but it comes into play a lot in the next class. If any of you guys go on to take pre-calculus, unit circle comes up like literally every day. It's just like an everyday thing because trigonometry is such a big thing in pre-calc. We're going to touch on this towards the end of the semester because we're going to touch on trigonometry towards the end of the semester, but I'm just preparing you that unit circle is a very big, hefty topic that will be coming up, towards the end of the semester and into future math classes. Okay, but we don't always have the unit circle because, again, r isn't always 1, right? If r is equal to 2, then you would have x squared plus y squared is equal to 4 because you would have 2 squared and 2 squared is equal to 4, right? So just keep in mind that, your circle can change depending on how big your radius is and also depending on where it's centered. In this case, this here is the base case where your circle is centered at 0, okay? So what I want you guys to do is I want to practice with an example here. I want to try to graph the following equation of a circle, okay? And it just has to be, just a rough sketch, okay? So let's say that we have the following. Let's say we have x minus 2 squared plus y plus 1 squared is equal to 36. So to try to sketch this, what we have to do is we have to first find the center of the circle, and we also have to find the radius of the circle. So that means that we have to put this in a notation that we can understand. So remember that the number that's over here is not the radius. Try not to confuse yourself, right? The equation of a circle is that constant on the right-hand side is the radius being squared. So what we have to realize is, okay, well, then this is really the same thing as 6 squared, right? 36 is just 6 squared. So as a result, our radius is just the 6. So we know then that r, when we are all said and done, r is equal to 6. And that means that from the center of the circle, we are going 6 units in any direction from the center, and that will be the graph of the circle. And now for the center of the circle, well, we still have, x minus 2 squared, and that should fit in with what we had before, right? Again, just to refresh everybody, the equation of a circle is x minus a squared plus y minus b squared is equal to r squared. So we already have x minus a number, right? Again, that negative sign is already built into our equation, which means we can just pull that number directly out. So we know that the center, I'm just going to call it C, the center of our circle, the x component of it is going to be just positive 2. Again, I really do try to not confuse, I'm sorry, I really want to try to not confuse you guys in saying I know it's x minus 2, but because the negative sign is built into the equation, we're just pulling out the positive 2 here because, again, it's not negative 2, it's x minus positive 2. Okay, so 2 is going to be the x component for the center of the circle. And now similarly, we see, okay, well, we have a y plus something, but y plus something is really the same thing as y minus another negative, right? All I did was I flipped the sign of the 1, so that way I can have that negative sign, because notice, again, we have the negative sign built in. Right? And this is what I was trying to tell you guys earlier, just a couple of seconds ago, that when we have a, x plus a number or y plus a number in the standard equation of a circle, that's really telling you that you have the negative version of that number in your center. So instead of it being, intuition might tell you, oh, great, the y component center of my circle is positive 1. Well, really, no, it's actually negative 1. So your center is 2, negative 1. And so plotting this on a graph, we're going to look at something like, I don't know, it's going to be 2 units over. So 1, 2, and negative 1 down. So 2, negative 1. So our circle center is going to be right about here. And again, this is just a rough sketch. I'm not, really trying to belabor this point here. But we're going 6 units in any direction, so that means we're going to be going 6 units up, which is going to be probably right about here, and 6 units over. Oops, I pushed my tablet. That's unfortunate. And about 6 units in this direction as well. So when we're all said and done, we're going to get something like this for our circle. Okay, again, the biggest things that I want you to realize is that we were able to get the center and the radius purely because of how we see the definition of the equation, right? We know that this piece is the radius being squared. So as long as we can just make it a number being squared, then whatever that number is really our radius. Okay, so that's how we get that direct correspondence to r being equal to 6. And again, we see that once we have it in the form of x minus a number and y minus a number, we can just pull those numbers directly in, and those become the x and y components of our center. Okay, so, and we would, if you really want to be technical, you can say, okay, so this is my center at 2, -1, and my radius here, r, is equal to 6. My radius is just 6 units going in any direction. Okay, so hopefully that's not too bad. So let's go ahead and do another example here together. And for here, what I want to see is, okay, what I want to say is find the equation of a circle with radius of 4 centered at -3, 2. So we're trying to find the equation of the circle. The radius is equal to 4, and the center is -3, 2. Okay, well, we know, again, that we're going to be in the form of x minus a squared plus y minus b squared is equal to r squared, right? So all we really have to do is just plug in our values. If our center is at -3, 2, -3 is my x component of the center, right? Please do not plug -3 into x. Remember, your center is A and B, right? So you're plugging -3 into A, and you're plugging 2 into B. So what we end up with is x minus a -3 squared plus y minus 2 squared is equal to, and remember, your radius is 4, but your radius is being squared here, right? So what you would be plugging in is 4 squared. Okay, and now we just have to simplify a little bit. So simplifying, well, we know that 2 negatives are going to cancel out to give us a positive, right? So 2 negatives, we get x plus 3 squared. And over here we have y minus 2 squared, nothing special about that one. And 4 squared gives us 16. So given the information that we started with up here, we can now get the equation of a circle in standard form, which is x plus 3 squared plus y minus 2 squared is equal to 16. Okay? All right. So on top of circles, there's also semicircles, right? So a semicircle is essentially just a half circle. But how do we get an equation for a semicircle? Well, let's just hypothetically assume that, for the purpose of this, our circle is centered at x squared plus y squared is equal to r squared, which means our circle is centered at the origin, right? So we have the base case, x squared plus y squared is equal to r squared. So the way that we get semicircles is by solving for a particular variable. It's by solving for a dependent and independent variable. Remember how I told you guys, it's really hard to see right now which is the independent and which is the dependent variable between x and y, because they're both on the same side of the equation and they're both having operations tied to it, right? So let's go ahead and let's solve for y. So solving for y, we are going to move over the x squared. So we're going to have y squared is equal to r squared minus x squared. And solving for y, that means we're going to take the square root because we have to undo that square, right? So we take the square root over here, take the square root over here. We see that the squares are going to cancel, and we have y. But notice that it's plus or minus y, right? Because when we, take the square root, when we're solving for a variable, it's plus or minus. So we have plus or minus r squared minus x squared. And what does this actually look like? Well, depending if we're talking about the positive value or if we're talking about the negative value, it can look like 2 different semicircles. So if we're talking about 2 different semicircles, well, we know that the full circle, when it's centered at the origin, is just going to be this, right? Just a rough sketch of it, where the distance here is going to be r. But when we're talking about just the semicircle, and specifically when we solved for positive and negative versions here, and we solved for y, then we're talking about the bottom and the top half of that same circle. So if we're talking about the positive value of square root of r squared minus x squared, we're only talking about this semicircle right here. If we're talking about the negative value, so if we're talking about this, the negative square root of r squared minus x squared, then we're talking about the bottom half of that same circle that we started with originally. And again, what I want you to notice is this here, that the radius of the semicircle would still be r. It would still very much be in line with it if it were a full circle. The only thing is that we kind of just chopped it in half. We got rid of half of the solutions, right? We're missing the top piece. And that should make sense because what did we do? We took the square root of y squared, right? And remember going way back how I told you when you're taking the square root of something, you're essentially getting rid of, some solutions, right? So it's the same exact thing here, right? When we're only talking about the positive value, you're getting 1/2. And when we're only talking about the negative value, you're getting the bottom half. Well, you might be asking yourself, okay, well, that's the bottom and the top halves. What happens if you tried splitting your circle the other way? And the other way would be, okay, well, we split this down, the center of it from left to right. What happens if we tried splitting it down the center from, the up and down, right and left? So what I mean by that is, okay, well, to do that, you would still solve for a variable, but instead of solving for y, you would now be solving for x. So instead, we're going to move y squared over. So we're going to have x squared by itself is equal to r squared minus y squared. And we're going to have the exact same thing where when we take the square root of both sides, we get plus or minus square root of r squared minus y squared. And once again, we see here, if we're talking about the positive value of the square root of r squared minus y squared, we're talking about the right semicircle. And when we are talking about the, too far. When we're talking about the negative version, well, then we are talking about this here, the left side, okay? And once again, we're missing that piece right there. Okay, so that's semicircles. That's how you would solve for a semicircle. It's essentially just solving for a particular variable. And what you should notice is the way that the semicircle points, so the direction that it goes, lies along the axis that you solved for and in the direction of the sign that you want in particular, right? So if we wanted this circle, or this semicircle in particular, notice how it's pointing in the x direction, right? It's pointing to the left. So as a result, it's going to be, you're solving for x, and because it's going to the left-hand side, it's the negative version of the square root, okay? And just to really reiterate this, if you wanted just the top half, notice again, we're going along the y-axis, right? It's going up this time, and because it's going positively up the y-axis, we know we're talking about the solving for y, and we know we're talking about the positive version of it, okay? Okay, one last thing that I want to squeeze into this lecture. Semicircles aren't too important, but it's good to know how to solve for them if you needed to solve for them. The last thing that I wanted to go over in this lecture is what happens if we have, an equation for a circle, but it's not in standard form. How do we still get the radius and the center of the circle? So let's look at an example together. Let's say we have x squared plus y squared. And this is minus 6x plus 8y plus 10 is equal to 0. Now, this looks nothing like the standard equation of a circle. Standard equation of a circle is where everything is still, inside of parentheses, right? It's not expanded. Standard equation is, again, x minus a squared plus y minus b squared is equal to r squared, right? So this is essentially saying, okay, we have x minus a squared. It's still not, we still have that square being applied to everything inside the parentheses, right? The direct difference is, notice how we have a 6x here, well, a negative 6x. That's as a result of expanding this term here for whatever, a happened to be. I couldn't tell you yet. And same thing with this positive 8y, right? That 8y is arising from expanding this term here. So essentially what we have to do is we have to find a way to go backwards. We have to take this whole piece and try to get it into standard notation. And when it looks like this, for just for the sake of this, I know again I'm not like big on definitions, but this is known as the general form of a circle. So if this here is the standard form, this is the general form. Okay. So to find the radius of a circle, you need to have it in the standard form. Same thing with the center of the circle. So what we want to do, the first step in solving this, is we want to put everything that's x with x, and everything that's y with y, and everything that's neither, we're going to move over to the other side. So other side of the equal sign. So what I mean by that is, okay, I'm going to put x squared over here, minus 6x. I'm going to put my y squared over here with my positive 8y. That's a y, not an x. 8y. And I'm going to move over my 10 to the other side. So I'm going to say, okay, negative 10 over here. And now what I'm going to do is I'm actually going to group them together. So I'm going to group this like this, and I'm going to group my y's together as well. And what you might notice is, okay, these are both really close to looking like quadratics in standard form. You know, quadratics in standard form are ax squared plus bx plus c. Well, what are we missing for both of these? We're missing a constant term, right? This plus c. Notice we don't have a plus or minus anything attached to them, right? So what we have to do is we have to complete the square. And this is when I had mentioned originally when we were doing completing the square, that this would come up at least one more time in our lessons. This is it. So you have to know how to complete the square, because if I give you, or if you come across a general equation of a circle and you need to know its radius and center, there's no way to do that to get it into standard form without knowing how to complete the square. Okay, so what our game plan is we're going to complete the square twice. We're going to do it for this one here, and then we're going to do it for this one here as well. So completing the square 2 times, so that way we can get things in the form of x minus a and y minus b, both being squared. Okay, so the way that we do this is, okay, we have x squared minus 6x. Remember our tool, right? Our tool is we're going to have b over 2 squared. That is our tool to complete the square. So I'm going to write for my completing the square for my x's, I'm going to write it in blue, and completing the squares for my y's, I'm going to write that in green, just so it's a little easier to follow along with, okay? So for over here, we have b over 2 squared. Well, my b is negative 6, right? So that means I'm going to have negative 6 squared, or negative 6 over 2 squared. Negative 6 over 2 is negative 3 squared, which is 9. Which means that what I'm going to do is I'm going to have x squared minus 6x plus 9, right? I'm adding 9 into the equation so that way I can complete the square. But remember, whatever we add to the left side, we know for sure we're also going to be adding to the right side, right? So plus 9. And just for the sake of it, we'll keep this black because that was the original constant, so negative 10. Okay, so we know then that we have x squared minus 6x plus 9. We added the plus 9 to both sides, so okay, that part's good. Before we even try to worry about factoring this, let's go ahead and deal with the y squared plus 8y. So again, y squared plus 8y, we're still going to do b over 2 squared, where b this time is positive 8. So positive 8, we have 8 over 2 squared is equal to 4 squared, and that's 16. So that means I'm going to add, so we have now plus y squared plus 8y plus 16, right? We're adding the 16 that we got from completing the square, and we're also adding 16 over here. Whatever we do to the left, we also do to the right. So let's try to factor these. Well, once again, we know what this is going to come out to be, right? And if you don't know, if you don't see it immediately, just do your normal factoring piece, piece by piece, right? So to try to factor this, you would look at, what this guy is, factors of this. So factors of 9 that would multiply to give you a positive 9 and add to give you a negative 6. Well, that's just going to be negative 3, right? Negative 3 and negative 3. So you would have x minus 3 times x minus 3, which is x minus 3 squared. And that's great that we have it already in this x minus a number squared, because notice what we needed. We needed x minus some number squared. So perfect. That one's already done. And in theory, if you really wanted to jump the gun, you could already start the center of your circle because you already have the x component. So we already have one piece of information done. We have two more to go, right? We need the y component of the center of the circle, and we need to figure out the radius. So let's move on over here. So moving on, now we have to factor the green piece. So y squared plus 8y plus 16. So we need two numbers, once again, that would multiply to give you a positive 16, add to give you a positive 8, and that's going to be 4 and 4, right? Y plus 4 times y plus 4, which is the same thing as y plus 4 squared. Solid. And that looks pretty close to what we needed, right? The only thing is that we needed a y minus something, right? But we'll deal with that in just a second. Right now, it's y plus 4. We need y minus something. So over here, we're just going to go ahead and condense our constants on the right-hand side. So we had negative 10 plus 9, which is negative 1. And then plus 16, so negative 1 plus 16 gives us 15. So we have 15 on the right-hand side. Okay, so the last thing that I want to do is I want to make, so I'm going to bring down my x minus 3 squared. That one's perfect, right? We're done with that one. I want to make this y minus something. And the reason that I want to do that is because once I get it in the form of y minus something, whatever that something is going to be the y component of the center of my circle. So we're going to have, instead of y plus 4, we're going to make it two negatives. Y minus a negative 4 squared is equal to 15. Okay? And now what we can see is the center of our circle is positive 3. See, even I make the mistake sometimes. You just have to catch yourself and be careful. So it's 3, right? Because the minus sign is built in to the equation that we needed. So it's 3 negative 4, right? We have the 1 minus sign built into our equation, and the negative 4 is the number that drops out. So the center of our circle is 3 negative 4, and now we just need to figure out the radius, right? Well, the radius is the square root of whatever this number is, right? Remember that this 15 is really r squared, right? So to find r, well, if r squared is equal to 15, r must be equal to square root of 15, right? Take the square root of both sides. You just get r is equal to square root of 15. And we don't care about negative values because radius is a distance. So radius has to be positive. Hence, we know that the radius is square root of 15. And we're done. We have arrived at our destination of finding the center of our circle and also finding its radius. Again, the key to this is first grouping them into the terms that match each other. So the x's with the x's, the y's with the y's, and the constants, you just move over to the other side. You throw it away, right? You put it on the other side. Then you complete the square twice with our super famous tool, b over 2 squared. You take whatever was the result of that. So in this case, we had 9 and 16. You add them to your respective parts, right? So we got 9 for the x's, and we had 16 for the y's. So you're going to add that into your groups, and then you're just going to factor. And once you have it factored, great, you might have to make a small modification like we saw here. Instead of it being y plus 4, we had to make it y minus a negative 4, just so we can see. But if you're getting good at this and you can already see that y plus 4 implies that the y component of the center is just going to be the negative version of 4, it's going to be just negative 4, then great. You can just jump to that. You don't have to make this little concession here. I just do that so that it's a little bit clearer for everybody why we got negative 4. Okay, so with all that being said, let's just do your last classwork assignment and then we'll wrap it up for today. So your last classwork assignment is as follows. It's the same thing. I want you to find the center of the circle and the radius of the circle. If I gave you x squared plus y squared plus 4x minus 6y minus 12 is equal to 0. So again, this is in general form. So your game plan here is you're going to convert it to standard form, right? And the way you're going to convert it to standard form is by completing the squares essentially twice. Okay, so give yourself a couple minutes, see what you come up with. All right. So first thing, right? First thing that we're going to do, we're going to group things together. So we have x squared plus 4x. Over here, we're going to have a plus. We're going to have a y squared minus 6y, right? We're putting the x's together and we're putting the y's together. And the piece that's left over, that negative 12, we're just going to move over to the other side. So adding 12 to both sides, we get positive 12 on the right. Okay, now we just have to complete the square twice, right? We complete the square here, and we complete the square here. I'm going to do the same thing, blue for the x's, green for the y's, just so it reads a little bit better. So we have b over 2 squared. B in this case is positive 4. So we have 4 over 2 squared, which is 2 squared, which gives us 4. So that means we're going to be adding 4 to both sides, and we're going to have x squared plus 4x plus 4 inside here. We're going to have that plus sign. Over here in green, we have b over 2 squared once more, where b this time is negative 6, right? So we're going to have negative 6 divided by 2 squared, and we already had this in the last example. Negative 6 divided by 2 is negative 3. Square that, we get 9. So that means that we're going to be having y squared minus 6y plus 9 is equal to, and now we have the 12, but we also have the 4 that we added to the x's, and we also have the 9 that we added to the y's, right? So we have to add that to both sides. Whatever we add to the left, we also add to the right. Okay, so now it's just a matter of factoring this. So factoring, well, I'm sure, if you guys need to do it, if you need to look at factors of c, that's totally fine. But you should be able to just gain some intuition from this piece here, which is your b over 2. Essentially, whatever your b over 2 is, that's what it's going to be when you factor it, x plus whatever your b over 2 is. So in this case, b over 2 is 4 over 2, which is 2. So that means that we'd have x plus 2 squared. And once again, I encourage you to factor this if you, by the normal methods. If you don't see that, that's totally okay. If you need to factor x squared plus 4x plus 4 by looking at the factors of positive 4, totally do that. Be my guest. That's totally fine. As long as you still arrive at, oh yeah, x plus 2 times x plus 2 is really just x plus 2 squared. Okay? You just have to make that jump to understand that this exponent is what's important. Okay? So sure, we have x plus 2 squared. And then over here, well, we have y squared minus 6y plus 9, right? Once again, we look over here. What was our b over 2 term? It was negative 6 over 2, which is negative 3. So we would say, oh yeah, this is going to be y minus 3 squared. And again, I encourage you, you're looking at two numbers that multiply to give you a positive 9 that add to give you a negative 6. Those would be negative 3 and negative 3. So you'd have y minus 3 times y minus 3, which is the same thing as y minus 3 squared, which is where I'm getting y minus 3 squared. And condensing all of these numbers on the right-hand side, 12 plus 9 is, 21, plus 4 is 25. So great, we have 25 on the right-hand side. Okay, and all we have to do now is we just need to convert, since we have an x plus something, we just need to make it x minus something, right? So x plus 2 is the same thing as x minus a negative 2. Remember, if we were to go backwards, two negatives would cancel out, right? Just hypothetically, if we needed to go backwards, two negatives would cancel out. We would have an x plus 2. But since we want it as x minus a number, then this is the form that I'm going to leave it in. So x minus negative 2 squared. And now plus, well, we already have y minus a number, so this one's already perfect. Y minus 3. That one's done. So y minus 3 squared is equal to 25. And so now we can say, great, our center of our circle is going to be, the x component is coming down here, so negative 2. And 3 is coming down, not negative 3, just 3, because again, that negative sign is already built into our equation. So it's, the center would be negative 2, 3. And what is our radius? Well, our radius is going to be the square root of 25, right? Remember that this is r squared, not r. So our radius is the square root of 25, which is just 5. Okay, so now we've solved for our center, we've solved for our radius, we got our equation in standard form, so hooray, we're done, and that's it. Again, the trick to this is just recognizing that you first group, you put your x's with your x's, your y's with your y's, and you complete the square twice, and that's it. Again, your tool to complete the square is b over 2 squared. Okay, guys, so try your hand at the homework. Hopefully it doesn't go too terribly. And if it does, feel free to let me know that it went terribly. Okay. Please try to keep up with your project packet. You guys, I was actually mistaken in today's class. You can actually do all the way up to number 4 at this point. So if you guys get all the way through number 4 done, you're almost halfway done with the project packet, and we haven't even had the midterm yet. So that would bode very well for you. Okay. So yeah, of course, feel free to reach out if you're having problems with that as well. And please start coming to office hours if you're having trouble before the midterm, right? I want to help you before the midterm, because if I try to help you after the midterm, well, the grade for the midterm would stand. Okay, so enjoy the rest of your day or night or whenever you're watching this, and I will talk to you next time. Have a great one, guys.